Imagine if suddenly the engine of our solar system stopped for 1 minute. What do you think would happen to Earth, the other planets, and even the fabric of space-time? Would we be thrown into absolute chaos? Could life as we know it end in an instant? In this video, we'll dive into such an extraordinary and frightening scenario. We'll explore how gravity, light, and heat would be affected, as well as the cosmic scale impact. Get ready to challenge your knowledge about the universe and discover what truly sustains our existence. What would happen if the sun stopped? Stay tuned until the end to find out. The sun is much more than a source of light. It is the true foundation of the solar system. Its colossal gravity keeps the planets in stable orbits, while its energy drives the natural cycles that make life on Earth possible. Without it, nothing we know would exist. To understand the impact of its absence, it's essential to recognize its role as a giant nuclear reactor. In the core of the sun, fusion reactions transform hydrogen atoms into helium, releasing an incredible amount of energy. This energy radiates into space, providing heat and light to all the celestial bodies around it. Additionally, the sun creates an area of influence called the heliosphere, which protects our solar system from dangerous cosmic radiation. It is literally our shield and our sustenance. Therefore, any alteration in its functioning would have devastating consequences, and this hypothetical scenario is proof of that. But what exactly do we mean by the sun stopping? In reality, the sun is not exactly moving like a car on a road. It rotates on its axis, has its own orbit in the Milky Way, and continuously emits energy. However, in this hypothetical scenario, we imagine two situations: the interruption of light and heat emission, or the cessation of its gravitational influence. If the sun stopped emitting energy for 1 minute, Earth would not immediately notice. This is because the light from the sun takes about 8 minutes and 20 seconds to reach us. In other words, the effects of the interruption would take a while to be felt. However, the idea of the sun ceasing to exert its gravity is even more catastrophic. Without this force, the planets would be thrown out of their orbits, plunging into chaos. It is important to note that this hypothesis is just a thought experiment, something that science uses to explore fundamental concepts. Although it is impossible in the real universe, thinking about the sun stopping helps us better understand how the laws of physics keep everything functioning in perfect harmony. Now imagine what would happen if the sun's light and heat were interrupted for 1 minute. Would Earth immediately become darker? Not exactly. As mentioned earlier, it would take about 8 minutes for any alteration in light emission to reach us. Therefore, for a brief period, life would continue as if nothing had happened. However, after this delay, darkness would take over the planet. The effects on temperature, however, would be much slower. Earth has an atmosphere and oceans that act as heat reservoirs, delaying energy loss. Even so, a minute of interruption would be enough to disrupt the delicate climate balances that make our planet habitable. Wildlife would also be affected. Many creatures depend on sunlight to navigate and carry out their daily activities. A minute without the sun could cause widespread confusion in ecosystems, especially for diurnal animals. For plants, photosynthesis would be temporarily interrupted, which, while not an immediate problem, would highlight the vital dependence on sunlight. Although the duration of this hypothetical event is short, it illustrates how incredibly sensitive Earth is to changes in the sun. Every second of light and heat counts in maintaining the order that sustains life on the planet. If the sun ceased exerting its gravitational force for 1 minute, the impact would be unimaginable. The sun's gravity is what keeps the planets, moons, and other celestial bodies in their orbits. Without it, the entire solar system would rapidly disintegrate. Earth, for example, would stop following its usual orbit and would begin to move in a straight line through space, following Newton's law of inertia. This would also happen to other planets, asteroids, and comets, creating a scene of absolute chaos. Collisions between celestial bodies would be inevitable, and the solar system would turn into a true debris field. Moreover, the sun's gravitational influence is essential for the stability of our local galaxy. Although 1 minute of absence might seem short, the cascading effect would be devastating. Entire planetary systems could collapse or be thrown out of their stellar orbits, causing irreversible damage. For us, Earth's inhabitants, the consequences would also be terrible. Even if gravity returned after a minute, Earth would already be far from its original orbit, possibly on a collision course with other celestial bodies or destined to drift through interstellar space. This would mean the end of the seasons, natural cycles, and ultimately life as we know it. To understand the consequences of such a strange event as the sun stopping for 1 minute, we need to consider the concept of space-time. According to Einstein's theory of relativity, space and time are intertwined into a single structure called space-time. The presence of a massive object, like the sun, curves the space-time around it, creating the gravitational force that keeps the planets in their orbits. If the sun suddenly stopped, the curve of space-time around it would also be affected. The change wouldn't happen instantly, as gravity, or more precisely, the alteration in the sun's gravitational field, would propagate at the speed of light. That is, even if the sun stopped immediately, the effects of this change in gravity would only reach Earth after about 8 minutes and 20 seconds, the time it takes for light and gravitational information to travel the distance between the sun and our planet. However, what really makes this interesting is the impact that this alteration in space-time could have. The absence of a massive body like the sun would not only alter the planet's orbits, but could also cause disturbances in the movement of other objects in the solar system, like comets and asteroids. These bodies might begin to move erratically, as their trajectories would be directly affected by the sudden loss of gravity. Additionally, relativity theory predicts that when massive objects like the sun cease to exist in their original form, there may be ripples in space-time called gravitational waves. These waves are disturbances in space-time caused by accelerated movements of large masses, as in the case of black hole collisions. If the sun stopped, it could theoretically generate a gravitational wave that would propagate through space, although, as mentioned, the effects of gravity would only reach Earth after a delay. Although a scenario like the sun stopping for 1 minute is purely hypothetical, science has been dedicated to simulating extreme cosmic events to better understand the limits of the laws of physics. Scientists and astrophysicists use complex computational models to predict what would happen in situations that challenge our understanding of the universe, such as the death of stars, black hole collisions, or the formation of gravitational waves. These simulations help explore scenarios that we can't directly test due to their scale or nature. For example, they can predict how a cataclysmic event, like a supernova explosion, a black hole collision, or even the death of a massive star, affects space-time, gravity, and energy propagation. When we apply this type of simulation to our scenario, the sun stopping suddenly, we can begin to understand the gravitational effects on the planets and the space around. Some theoretical simulations suggest that, although the sun stopped instantly, the planets would continue moving along their orbits for some time, but without the necessary gravitational force to keep them on their paths. This could lead to destabilized orbits, causing a chain of events that would ultimately result in the dispersion of the planets and other objects in the solar system. Moreover, the sudden absence of light and heat would drastically affect Earth's biosphere, paralyzing processes like photosynthesis and freezing climate cycles. Another important aspect of theoretical simulations is that they help us put these scenarios into context. For example, real cosmic events, such as black hole formation or supernova explosions, also have far-reaching effects on space and time, and help us understand the implications of a sudden absence of mass or energy in the universe. In some respects, science can use these examples to predict the consequences of something as improbable as the sun simply stopping its energy emission. Although the scenario of the sun suddenly stopping seems fascinating and even terrifying, it is, in practice, completely impossible. This happens due to the fundamental laws of physics, which govern not only the behavior of celestial bodies, but all matter and energy in the universe. First, the inertia of stars, like the sun, prevents such an abrupt change. The sun, being a massive star, is in a state of dynamic equilibrium, meaning it constantly generates energy through nuclear fusion in its core, which keeps it stable. The idea of the sun simply stopping is incompatible with the laws of thermodynamics and the conservation of energy, which state that energy cannot be created or destroyed, only transformed. The sudden cessation of its nuclear activity would violate these laws. Furthermore, the very nature of stars is such that they cannot stop functioning without an extraordinary external cause, like the gravitational collapse of a star, to form a black hole. The Sun is nowhere near reaching this stage in its life, as it is in the main sequence phase, a stable phase that will last for billions of years. Even if, somehow, nuclear fusion stopped, the Sun would still continue to move in its normal orbit for a time, as the Sun's mass inertia would prevent any sudden alteration. This type of question, although impossible, is an excellent mental exercise to expand our understanding of the laws governing the cosmos. Additionally, it leads us to question the limits of physics and explore new frontiers of knowledge, even if the scenario itself never comes to pass. Throughout this video, we explored the fascinating consequences of a hypothetical event, the Sun stopping for 1 minute. Although, from the perspective of modern physics, this scenario is impossible, it helped us understand the vital importance of the Sun in maintaining the stability of our solar system and life on Earth. From its gravitational influence, which keeps the planets in orbit, to its crucial role in providing light and heat for vital processes, the Sun is truly the engine of the cosmos. Reflecting on what could happen if the Sun stopped leads to a deeper understanding of how the laws of physics, such as gravity and relativity, work on a large scale. Furthermore, these thoughts remind us of the interconnectedness of all elements in the universe, how we depend on an apparently ordinary but essential star for our existence. If you enjoyed this journey through the cosmos and the intriguing questions that arise when we explore the impossible, subscribe to the channel and share this video with other universe enthusiasts. Continuing to explore the mysteries of the cosmos is an adventure that never ends. See you next time.